As we recall from Math 2 last year during Unit 3 Plus, and possibly in regular Math 2, we also did a little bit of this. We talked about the complex plane, and so the horizontal axis, typically the x-axis, has been replaced, and it's called the real axis, but it works the same way, positive numbers this way, negative numbers that way. And the vertical axis is the imaginary axis. And so we have those two things happening. And so we can plot our complex numbers in the form of a plus bi as ordered pairs a plus b. And you'll notice on this picture they're not plotted that way. They're drawn as vectors, which is something we discussed specifically in 2 Accelerated in 3 Plus, but where the tail is here at the origin and they go to the point that we would have plotted for that grid. So what the first set of the problems, I'm just going to do a couple of the problems for you and have you finish the rest of the ready on your own for a warm-up. But I'm just going to remind you really fast of what it was that we were doing. And so -3 plus for I, which is this vector right here, graphs as -3 and 4. And excuse the sloppiness, I'm using my finger, so if it looks a little funky, and it does, is that point, -3, 4, and so it's just the same idea. So you'll finish the other two, but I'll just do the next one to get us going. Number 4 says we're going to graph as a vector. So the first thing we're going to do is plot the point. So we've got -5 and -3, and so that's my point right there. And then to make it a vector, I'm going to go from the origin to that point and draw an arrow. You want to do it as straight as possible. You know, mine's a little curved. It's not the end of the world. The idea is direction and position. And so that is my answer. So go ahead and do the last. I've done number 4 for you. And number 1, go ahead and do the remaining 5 problems and pause the video, and we'll come back and I'll have the rest of the answers for you. Are you paused? Did you pause yet? Pause. Oh. So now I've plotted the answers, so you'll notice number 2 and 3 went really fast. All I really do, I don't even pay much attention to the vectors, and I probably should. But since it's 5, 2i in my picture over here, 5, 2i, I'm going to go over here and it's just 5, 2, and this one is 1, -6. And so on these, I plotted the points and drew arrows from the origin. It's just really, really straightforward. I hope it went as easily for you. We'll move on to our lesson today, which we're going to spend time taking our polar lesson, which we did yesterday, and putting, instead of on real numbers on the polar planes, we're going to put complex numbers on the polar planes. And so there's a lot here that's a little bit tricky and may seem overcomplicated, but honestly, complex numbers on the polar plane are so much easier than real numbers on the polar plane. And I know that you're thinking either, well, that real numbers were really easy, or thinking you're lying because real numbers were really hard, you can't be right. But I promise you, other than number 2, which we're going to spend some time making sure we understand what's going on, it is going to be shorter. So first thing we're going to do is just kind of remind ourselves of what we did yesterday. So I'd like you to go ahead and try number 1 on your own. Use yesterday's notes, pull them up, and try to write the polar coordinates for that regular point, 2, 5, and find r and theta. And if you need to remember r squared is equal to x squared plus y squared. Y squared, and the tangent of theta is equal to y divided by x. And that way you can use those to help you figure out what's going on. Go ahead and do number 1, pause the video, and come right back when you're finished. So by following this, I get r is equal to the square root of 29, since 2 squared is 4 plus 5 squared is 25, so the square, and 4 plus 25 is 29, so the square root of 29. And then for theta, I did y divided by x, which was 5 divided by 2, and then took the tangent inverse of that expression and got 68.2 degrees because it says in the instructions. So with that in mind, we're going to move on to the complex plane now. And so the complex plane is, by its very name, feels more complex. But we're going to use the same ideas that we already have to help us. And so we already know a couple of things about everything we've got going on. For example, x is equal to the sine, is equal to r times the cosine of theta, or the radius of the circle times the cosine of the angle. And y is equal to r times the sine of theta. We're going to use this to help us tremendously. So if you think about our complex number, 5 plus 2i, which would be the point 2 comma 5 on the real number line and the point what we plot on the complex number. And so we're going to actually go with the general form. In general, any point a comma b represents a corresponding complex number, a plus 2b, a plus bi. And how can a complex number be written in polar form? Or in other words, how can we use r and theta to describe the complex number? So this is really simple. And I know it's going to feel a little awkward, but it's really simple. A is x. So x plus yi, is our complex number. And so all we're going to do is take these that we already know and substitute. And that's it. So it's really simple. We're going to do one tricky thing at the end, but this is it. So we're going to have r times the cosine of theta plus r times the sine of theta I. And we're going to clean that up a little bit, but we are really done. Now, we don't want to put I at the end because I at the end makes us think that it's a weird thing, and we want I to be first, where at the same time we know that both of these have R in common, and so we can deal with that in a minute. But first we're going to rewrite it. So we've got R cosine theta plus I times R sine theta. And so then we're going to pull out R. And this is trigonometric form. R times the cosine of theta plus, excuse me, that does not look like a plus sign. That's worse. Plus I times the sine of theta. And that way we only have to use R once, and it's really, really, really easy. I'm going to refer to this probably for most of our notes more in this format than the one below, mostly because this is, I already typed the notes and I don't want to change them, but your homework will refer to it in the format below the last answer because that's trigonometric form, just because it's just easier to pull the R out. It doesn't make much difference in the work that we do. But go ahead and make sure you understand what just happened there. All I really did was substitution and then a little bit of manipulation at the end where I factored out R. Nothing really changed. It's honestly easier than I remembered. So we'll continue in the next video to explore some more.